Just to get settled so that we get started. Thank you. I'll tell you in a minute. All right, everybody, are we ready to get started? Everyone have a good lunch? Thank you to everybody who came back on time, and thank you for Doug for bringing back Gil early. We appreciate it. You're tired of it. So up next, we have the Saltstone Reliability presentation by Aaron Staub. Aaron, you ready?
How do we initialize it? All right, well, good afternoon, everyone. As was said, my name is Aaron Staub. If you don't know me, I've been working at Savannah River Site in liquid waste for a little over the past 19 years. I've spent the last 3 of those managing an engineering group that supports high-level waste melter operation within the DWPF. Just maybe a little higher would help. And also supporting the saltstone production and disposal facilities. And as you can see, the topic I'm presenting on is reliability enhancements in saltstone. And I'll acknowledge that is a rather esoteric and dry-sounding title. And so I wanted to spend a minute to explicitly answer a question that I often have when I'm in your position as an audience member, and that's, why should I have any interest in this topic? Why is it important? And what I'll tell you is, I know Mark spoke this morning about how the liquid waste system integrates, and you guys have the placemats that show all of these facilities. And it's pretty clear that there's a lot of work that goes from retrieving waste from a waste tank and characterizing it, doing batch preparation and qualification, all of these interim treatment processes until you finally get to a disposition into either glass for high-level waste or grout for low-level waste. And saltstone, which is in the bottom right corner of your diagram, saltstone is the last link in the chain for low-level waste disposition. And what that means to me is it effectively represents the upper speed limit to how quickly we can accomplish our mission. The bulk of the volume of the waste in the tank farms is going into low-level waste. And what that means is we will close tanks no faster than we safely and reliably operate this facility. So that's the elevator pitch as to why you guys should be interested in this. I've got an agenda. I'm not going to read these bullets to you. What I'll tell you is what I desire to accomplish is to communicate to you guys a pretty comprehensive history of the saltstone facility, because the expectations of the facility have changed a lot over the years. And so I want to talk about where we started, where we've been, the work we've done to get us to where we are today, and then where we see ourselves going in the future. And to kick off, I want to do a little bit of process overview. And I'm a chemical engineer by education, so this is sort of my bailiwick. I'm very comfortable in this type of environment. But this is a graphic we use in a lot of our training packages and a lot of our presentations, and I wanted to make sure we all had a common understanding of what this facility does and how it operates. So to start off, we'll start off over here on the left-hand side of this screen. And We have essentially a dry end part of the facility and we have a wet end part of the facility. And saltstone is a cementitious waste form that comes from blending the decontaminated aqueous salt solution from historically ARP and MCU, and in the future SWPF operation. And we blend that with a mixture of dry materials that undergo hydration reactions to create a cementitious product. Specifically, we use 3 different components. We use Portland cement, which if you've ever done any sidewalk work or anything like that at your house, you're very familiar with. It's a common industrial product. We also use Class F fly ash. That's less common, but fly ash is essentially a waste product from coal-fired power plant operation. We have a variety of power plants within the state of South Carolina that supply us. We also use ground granulated blast furnace slag. That's a mouthful, but it's essentially another waste byproduct from steel production. When you run a steel furnace, the stuff that's not steel is taken off as slag. Each of those components are stored separately. You can see I'm showing we have 4 different storage silos, so they're stored as raw materials. We have 1 spare, and then they are blended in our facility to a specific recipe. And currently that recipe is 45% of our component is ash, 45% is slag, and the balance, that 10%, is the Portland cement. Those are mixed in batches in a weigh hopper. Each of these silos has an isolation valve and an air slide that leads to this weigh hopper. And we make up batches of premix in 3-ton increments, so 6,000 pounds. And everything that happens over here is batch processing. We go silo by silo, discharging each component into the weigh hopper, and it's going to then layer in there, sort of like Neapolitan ice cream. The weigh hopper is observed in the control room to hit our recipe targets. For a 6,000 pound batch, that's 2,700 pounds ash, 2,700 pounds slag, and 600 pounds cement. Once they've hit those recipe targets, the weigh hopper discharges into one of 2 air blenders. The air blenders do exactly what they sound like they do. They use air to blend. Each blender has a series of air cannons on the bottom, and once the material is transferred from the weigh hopper to the air blender, those air cannons are pulsed to give a fully homogeneous, well-mixed component that at that point we call premix. When it's all blended into that 45-45-10 recipe, we call that premix. So if you hear me say the word premix a few times, that's what I mean. We've got 2 blenders, which means we can run them out of phase. So while one blender is actively in its blend cycle, the other blender can either be receiving material from the weigh hopper or it can be discharging to our main process building. Exiting the air blenders, we go over, and this is shown as a very short line on this chart, but it's quite a physical difference in separation. But we go over to our main process building where we have the premix feed bin. And the premix feed bin is where we transition from batch operation to continuous operation. Because premix that is accumulated in the feed bin is fed continuously, again through a weigh hopper, and then through 2 screw feeders. And these screw feeders are what provide the process control function. They determine the rate at which we are going to be consuming dry material. Nominally, we talk about everything in terms of the dry feed rate quoted in tons per hour. And a nominal feed rate for us would be 30 to 35 tons of dry material per hour. It is a very high instantaneous rate process. That's a lot of material to be moving. Coming out of the screw feeders, that premix is discharged into our mixer. This is where we have our first interaction from the wet side of the plant. We will be simultaneously, today, we receive from the tank farms the decontaminated salt solution into a salt solution receipt tank. We actually have 2 of these vessels. I'm only showing 1 for clarity. These are 60,000 gallon vessels. They have their own supplied transfer pumps that provide flow to the mixer, which is where you now contact the dry material in the liquid feed. You've got about a 30 or 40 second residence time in the mixer before what is now a fresh saltstone slurry is discharged to a head tank, which we call our grout pump hopper. And then out of the hopper, we go to our grout pump and then through our transfer line to one of our disposal units. Currently, we're actively processing into disposal unit 6, which is the first of our megavault designs. This is obviously sort of a cartoon format. I've got some photographs later on of some of the actual process equipment so you can see what some of this technology looks like. It is a fairly straightforward process. There is a lot of engineering that goes into how to make it reliably operate. Okay. Some background. So the facility was originally commissioned in 1990, and it was initially designed with an operational throughput of 6 million gallons of salt solution per year. All the numbers I'm going to give you are on a salt solution basis. That number was driven by the expectations in that time of how quickly we felt we could dissolve salt and provide feed to this facility. However, as I said before, we operate at a very high instantaneous rate. If we are operating at 30 to 35 tons per hour of dry materials, we are consuming salt solution at a rate of about 80 to 90 gallons a minute. So if I had two 55-gallon drums up here, we are consuming that quantity of material every 90 seconds. So at that instantaneous processing rate, we could operate on a days-only operating schedule. So originally, Saltstone was intended to run days only, Monday through Thursday, unlike facilities like DWPF, which operate 24/7. Unfortunately, the salt program that was going to provide that feed for us to disposition was delayed in the mid-1990s, and that took away a lot of our customer demand. Now, salt is not the only producer of low-level waste for us. We do get a small volume of material from our effluent treatment facility on site. That is a water polishing plant that treats a lot of the evaporator overheads. But the quantity of waste it generates for us is on the order of a few 100,000 gallons per year. It's really not a very significant volume contributor. And so what that means was for most of the 1990s and into the early 2000s, the facility was generally destaffed. If you drove by it, the gates would be closed, lights would be off. And we would only staff it after we had accumulated a significant inventory, and then we'd come up and operate it in a short operating campaign before shutting it back down. So that was sort of how life was until the mid-2000s. And when we get to the mid-2000s, we had our interim salt disposition project, which was the forerunner to SWPF, and that was our ARP and MCU facilities. Now, ARP MCU facilities put us back into business. Throughputs typically range, I already got my buttons messed up. Throughputs typically ranging in about the 1 to 2 million gallons per year range. Nothing approaching our original design basis, but enough for us to routinely operate. We had a small volume of DSS that we had to process that had a higher cesium content than our original design basis that forced a redesign of several of our major process components. One of the important parts of not being able to operate routinely from 1990 until the late 2000s is we didn't gain a lot of operational experience. Until ARP MCU came online, we really only treated a little over 3 million gallons, which would be 6 months of our design basis capacity in that 16 to 17 year interval. So a lot of our operational experience comes after the introduction of the ARP MCU facilities. In the 2009-2010 timeframe, that experience was enough for us to determine we were having unsatisfactory reliability. Specifically, we were having a lot of pluggage events, typically either right at the outlet of the mixer or right at the outlet of our hopper on the suction side of the pump. And anytime you had one of those, it involved a very labor-intensive recovery effort to go in and break apart the piping systems, clean them out, and reassemble them. That drove us to kick off what we call, and we love project titles out here, we kicked off what we call the ELOD project, which was the Enhanced Low Activity Waste Disposition Project. And the ELOD project had a very focused technical approach, and it was split into 2 phases, phase 1 and phase 2. Phase 1 were those modifications we deemed necessary to ensure the reliable and repeatable day-to-day operations of the plant. We wanted to be able to come in, start the process up, operate for a full shift, shut the process down with very high confidence we weren't going to have any operational issues. There were several different things associated with that. I'll highlight a couple. Keep my buttons correct. One of them was a larger grout pump hopper. So I told you before we had to do some modifications to accommodate some higher cesium feed. That generally drove us to minimizing volumes within our facility to keep the source terms small. Unfortunately, that meant we were very vulnerable to any sort of flow deviation. And I'm not sure if you've ever made grout for like a tile job, but it's really sensitive to how much water you're adding. It's too thick, it's too thick, it's too thick, and all of a sudden it's too thin. Having small process volumes meant we were very at risk to flow deviations causing a viscosity problem, and going to a larger vessel was a significant change. Another significant change was changing our shutdown automation. The original control system was entirely driven by timers. So you can imagine when we're shutting the process down, what we want to do first is turn off the dry material flow, let that material process through the system, use the liquid feeds to flush all of our process equipment, and then finally suspend liquid flow. And that works great as long as everything is behaving according to the timetable that you expect. But if, for example, if that timer is to keep the liquids on for 30 seconds, if you haven't got all the dry material out of the system within 30 seconds, you're going to get a result you don't like. And so we implemented what we called a smart flush sequence, which is an automated sequence that actually used the process indications because we would know what we expect to happen as we shut the process down. When you turn off the dry material, you're putting less stuff into our systems. You would expect flows to decrease. If flows are going to decrease, you would expect transfer line pressures to decrease. We have a density monitor that monitors the density of the product. You'd expect the density to decrease. And so what we implemented were actual process set points to let the control system know when it was an appropriate time to advance to the next part of the shutdown. All of these modifications were field installed in the 2012 timeframe. I would say it's one of the most successful things we've ever done. We have had 0 system pluggages since the implementation of these modifications in 2012. So again, phase 1, highly focused on reliable day-to-day operation. However, that day-to-day operation was still only in a 1 to 2 million gallon per year operating range, and we know the future is going to be for much higher throughputs. So phase 2 was scoped with an eye towards SWPF and recognizing we need to operate with much higher availability. And unfortunately, the graph colors here are terrible for how far away you guys are looking, but I put a chart on here to show our annual production rate that we can achieve as a function of the number of operating shifts. And so what I'm showing here, at 1 operating shift, you're right at the 6 million gallons. If you go to 2 operating shifts, so that's 7-day per week operation, that's just the extra few days you get, that gets you to around 9 million gallons. And if you go to 3 operating shifts, you actually get a proportionally larger bump than you would expect. You can get up to a little over 13 million gallons. And the reason that's important is if you go to 3 operating shifts, you now create the potential for some periods of round-the-clock operation. And that brings in an efficiency because you aren't having to shut the process down at the end of each shift and bring it back up. You can just keep it rolling through a shift change. So the modifications in phase 2 included some balance of plant modifications to support extended shifts. Some other things to improve the flexibility of the facility. I put as an example on here an upgraded dust collector. We have dust collectors anywhere we have dry material because we operate under an air permit that doesn't allow us to discharge this stuff to the environment. And the original dust collector was sized to accommodate 1 truck. The material comes in on tanker trucks. It is pneumatically blown into the top of the silo. The dust collector has to be able to evacuate all that air. The original one was only big enough to handle 1 truck. Again, at the lower throughputs we've been experiencing, that hasn't been an issue. But to be available for SWPF, you could certainly imagine a scenario where, you have the best laid plans. We want a truck to come in every hour, but if one catches a flat tire and gets delayed, you'd like to be able to do 2 or 3 at a time. So those are the types of modifications in phase 2 that we're implementing to try to give us the most amount of flexibility, as well as acknowledge that the plant is now 30 years old and we're only just now expecting to really rely on it. So we're addressing a lot of equipment obsolescence. So some of our older air compressors are being replaced. The original screw feeders are also being replaced. So again, phase 1, make the day-to-day process reliable. Phase 2, be prepared for SWPF. Okay, so I'll show you some of our process equipment. So these are the dry feed silos, and again, that is a 4-pack. They are all identically designed. If you're at the very, very top of the silos, you're about 150 feet off the ground, and you will have, if you look to the west, a great view of Plant Vogel. The dust collectors are up here, and each of these silos has a storage capacity of about 600 tons. So you can hold a significant amount of material in these. This is inside our process room, and this is a saltstone mixer. The mixer sits up on a platform above the rest of the equipment in the process room. So I think all of these pictures I'm showing you are taken from this platform. It just depends which way we're looking as you're on that platform. But we are looking at the discharge end of the mixer here. So these are some mechanical seals that keep all of the waste on the inside. This is the main operating body of the mixer. This is the inlet where the liquid salt solution comes in, that 3-inch yellow pipe. And it's a bit difficult to discern, but right back here is a chute where the premix comes in from the roof above. So dry material comes in here. It falls onto some screw feeders that move everything forward. Then you have the liquid introduction, and I think the liquid introduction is actually right about here on this picture. And then you can see within the mixer there's 2 shafts with mated paddles at each location. And so these shafts co-rotate. Each one of these, as you notice, is indexed so that it is continuously in close contact with the paddle next to it. So those paddles are effectively self-cleaning. It's very close tolerance, and you'll notice it's also very close tolerance with the wall. Very high rate of shear, so within about 20 or 30 seconds of residence time, you go from a completely dry, unwetted material to a very smooth, flowable, homogeneous product. I've had a lot of people describe fresh saltstone as being of the consistency of latex paint. It's actually much thinner than latex paint. You'd be astonished that it turns into the final product that it does, because it actually has a consistency very close to chocolate milk. So it's highly flowable. That's why we can use the very large disposal units we have and not worry about it not being self-leveling. So that's the mixer. This is our hopper. So, okay, I lied. We're taking this picture from the bottom now. So the mixer platform is right up here, but it discharges to the hopper. Again, this is about a 450-gallon vessel. It has a conical shaped bottom. It is agitated, and we normally operate it at an operating level of about 300 gallons. It is supplied with a number of spray jets and flush nozzles inside to keep the interface clean. Any place grout might have a tendency to accumulate. Coming out of the hopper, you go to our grout pump. This picture is taken from above again. And this is a peristaltic hose pump, and it's one of the biggest hose pumps I've ever seen. It has 2 pump heads. Each of these pump heads is about 4 feet tall. And each time that pump rotates 1 full revolution, it will discharge 10 gallons of product. And effectively what you have is a rubber hose that comes in the bottom and makes a 180-degree turn to the top, and there is a pressing shoe on the inside that rotates with the motor, and that pressing shoe squeezes that hose like a tube of toothpaste, forcing material down the transfer line within the vacuum behind the pressing shoe, pulling in fresh material from the hopper. It has a maximum output of about 180 gallons a minute, and when we are typically operating, we're flowing grout at about 135 to 140 gallons per minute. All right. Downstream of the grout pump, we have, again, a small amount of process instrumentation. We can monitor pressure, we can monitor flow, we can monitor density, but after that, it exits the process room and then goes through a series of 3-way valves to direct it to whichever is the active disposal location at that time. So what I've tried to get to at this point is sort of where we've been with expectations of the facility and what we've done to prepare ourselves for SWPF. And I think in large measure, we've done a very good job. We acknowledge we have a couple of gaps that we continue to work on. I'm going to talk about 2 of them. So one of our residual challenges has to do with mixer wear. And I showed you a clean picture of the mixer a little bit ago. This is one that you can see has had some process use on it. And we have an issue with abrasive wear on the paddle tips that are directly upstream of our salt solution inlet. And that may be kind of counterintuitive, since I just told you that fresh saltstone has the consistency of chocolate milk. You're probably not worried about abrasion from your chocolate milk. But you have to remember that this piece of equipment is about 8 feet long. and it's only chocolate milk at the outlet. At the upstream side, it's dry material and liquid feed coming in individually, and we have every spectrum of rheology that is occurring within those 8 feet. I tried to think of a decent analogy. The area that we're concerned about is an area where we have unwetted solids. And the best I could come up with is, because I have young kids and they drink a lot of chocolate milk, is they throw the Nestle's packet into the milk, and some of it incorporates right away, and some of it doesn't and balls up on the top. Those are unwetted solids. And of course, the kids have to stir them for a while to get them incorporated. We have that same thing happen in here. When those solids are unwetted, they are highly abrasive. And what that results in, and again, I don't know how well these pictures show up, but these paddles here look great. They have nice, sharp tips on them. You're not worried about them in the least. You can see how straight those lines are. As we come over here, this is more towards the back, you can see some shiny areas where they've been worn a little bit. And then particularly, this one has a very good profile. You can see how much mass loss has occurred on that paddle right there. Now, this doesn't have an immediate impact on the mixer itself. The mixer is going to continue to move material and blend very well. But what it does is it creates a gap between that eroded paddle tip and the wall. And I showed you on the clean picture how narrow that gap normally is. As that gap continues to open up, you will get an accumulation of solidified saltstone that adheres to the wall of the mixer itself. And it will start out being a thin crust, but as it opens up to this size, that's about 3/4 of an inch, you effectively will begin to create a rind within the mixer that is reducing the overall cross-sectional area that's available for flow. And when that gets significant enough, you actually won't be able to de-inventory all of the dry material that you're sending to the mixer. And that dry material will then begin to accumulate in the chute upstream. Now, we know when this is happening. It's very easy to detect. We have a plexiglass window on the chute that the operators can observe with a camera. We've installed ultrasonic probes that will alarm on the DCS when this occurs. So we have all the monitoring ability necessary to know when this is occurring. The problem is what you have to do about it. Because what you have to do about it is replace those worn paddles. And Murphy's Law never takes a day off. And so the way you do that is, if I can back up here, the way you do that is you take the top of the mixer off, you remove these mechanical seals, and the paddles that you're concerned about are these guys right here, which means, and these shafts are all one piece, which means you have to remove about 40 completely intact paddles that look like they just came off the showroom floor to get to the 12 that you're actually concerned about. We have done this 2 times in the field, and both times those outages have required about 3.5 to 4 weeks to go execute. Now, in support of ARP MCU throughput, that hasn't been that big of a deal. What we've seen as a frequency is having to do that about every 2.5 to 3 million gallons of salt solution processed. Under ARP MCU operation, hey, that's every 18 to 24 months, so we can accommodate that. But what you know is if we're going to operate at 6 million gallons a year from SWPF, or more if you include ticker, taking a month of downtime every 3 million gallons is effectively a non-compute. We just can't tolerate that level of outage time. So we know we have a problem. So here's what we're proposing to go do about that. Now, we've evaluated a couple of quick fixes. The original mixer was supplied with steel paddles. We tried a somewhat harder metal called Astraloy to see if a more abrasion-resistant material would be better. I would describe the improvement as, in the noise. It was very hard to see if that was any better. We've assessed a couple different paddle geometries to see if the paddle geometry was an issue. That hasn't done us much good. What we are currently evaluating is, instead of using paddles, using additional screw feeder sections. So those are screw feeder sections right there. Because these paddles are upstream of the salt solution inlet, they're not highly engaged in mixing action. So to see if we get any better performance, we've removed those and just gone back with screw feeders. And We've operated about 1 million gallons since we've installed those. We probably need to go another million before we can really determine whether that's had any positive result for us or not. But you always want to have another idea in the pipeline, and this is the next idea. This is what is shown on the screen as a two-piece paddle, and to date, all the paddles we've ever used are single pieces. That's why they have to slide all the way off the shaft. With this type of design, you would essentially have a hub that stays in position on the shaft, but you would have a sacrificial tip that's bolted to that hub, and as it wears, rather than ask the mechanics to go in and remove all of the paddles, they could leave the paddles in place and only just remove that worn tip. Talking with them, their estimation is they believe a design like this would allow us to reduce the outage time from 1 month to 1 week. That is a huge savings, mostly because they don't have to deal with the mechanical seal, and they don't have to re-index those paddles because they have to go back in a very certain sequence. The other thing that does is it brings into position the opportunity to potentially get a little bit more exotic as to what the material of construction of that tip is. Because you can envision us potentially using some pretty abrasion resistant and hard materials to use as the tips while leaving the base hub as the softer material. So this work has been pursued in consultation with the SRNL National Lab. We have mocked this up on rapid prototyping machines, and they are now proceeding to actual fabrication of the metal paddles. I think the first set of these was fabricated last week. They're going to make a total of 6 pair for us, and we will then take them to our spare mixer and install them on the spare mixer to prove that our maintenance mechanics can actually do this replacement in a clean area before we would ever ask them to do it in a contaminated environment. The goal would be twofold. If we can use a harder tip to extend the frequency with which we have to do this, so don't be doing it every 2 or 3 million gallons, get that out to more like 8 million gallons. So potentially we're only doing this once a year, and then get the outage time down from 1 month to 1 week. All right, the last thing I want to talk about, probably my favorite piece of equipment in the whole facility is that grout pump. It is such a simple pump. It operates so reliably. It has tremendous suction, and we've really never had a problem with the operation of the pump itself. However, it does have a weakness, and that weakness comes in when you talk about foreign materials. And foreign materials are an inherent risk with the dry feeds that we use. Now, I doubt anyone here has ever opened a bag of ready mix and found a crescent wrench or a rusty bolt or, junk fasteners, but cement is an engineered product. Slag and fly ash are not engineered products, they're waste products. And we have observed over the years, we have a lot of foreign material that comes in. Now, for concrete construction, that's not a problem. The way that they batch and place construction cement concretes, they're probably unconcerned at a couple of random fasteners that come through. But for our process, where it's going to go through a pump, where you're going to have a pressing shoe squeeze really hard into a rubber hose, something sharp is a risk. Now, we have, I think, expended every available effort to excluding those materials. We actually use, gosh, I'm never going to remember this, we actually use magnetic separators. Every bit of dry material that's unloaded into our silos goes through a magnetic separator to try to remove as much foreign material as we can. But I don't think we can ever guarantee that you're never going to have foreign material in there. And I've got a couple of pictures to show this. So this picture right here was taken from inside one of our pulsation dampeners that's downstream of the pump, and it's showing you the circumference of the pipe with a little bit of grout remaining in it. And what that guy is a piece of welding rod that was able to get through the process, and of course that's going to be sharp. These guys are screw feeder sections that were removed from the mixer during the rebuild, and you'll notice that there's chunks missing from those edges. So that's not abrasive wear, that's a brittle fracture that something else was hard in there and came in and caused that damage. So we know that the separators aren't going to be 100% effective. So if you have the potential for a hose rupture, what does that mean? Well, when you have a loss of hose integrity, the first thing we're going to do is we're going to shut the process down and we're going to flush all of our critical equipment. The mixer is an expensive piece of equipment. We want to flush that. The hopper is a custom-built tank. We want to save that. And ultimately, to do all that, we would desire to flush about 1,800 gallons of material through the process. We do have an overflow container, but that overflow container is limited to a maximum storage capacity of about 450 gallons, because if we put any more material in it than that, we can't pick it up with our crane. Which means today that the balance of that flush volume between these two numbers wind up getting directed to a low point drain tank outside adjacent to our salt solution receipt tanks. Additionally, there's a pretty heavily involved recovery requiring an outage, because we have to go then break apart all this piping and perform inspections, and then there's going to be some level of repair associated with the grout pump. I have no idea how well this shows from back there, but this is another picture taken from the top. So there's our grout pump again, and then this is our overflow container. That's the 450-gallon guy. And what we are currently pursuing is a design that is going to install a second and separate recovery pump that will pull suction off of this overflow container and will interface back with our transfer piping, and instead return that flush material to the transfer line and actually send it out to the SDU, which is ultimately where we want to send this stuff to begin with. And so the design for this has been completed. Construction is likely not going to get started for a few more months yet. But this shows essentially a new pump that would be installed kind of in this area right over here that would pull suction and put in a new three-way valve to send it to our transfer line out to the SDU. The intent there would be, in the event that you have a grout pump hose rupture, as that material is being transferred into this overflow container, this pump can just continually take suction out of it and maintain the level at a low level within our overflow container. Okay, that's a lot of talking from me, so I have a brief summary. The things I wanted to fundamentally communicate is, again, the expectations of saltstone have changed a lot over the years. From the 1990s and the expectations of throughput, to the higher curie contents into the mid-2000s, to the introduction of SWPF with much higher throughputs today. We had operational experience during those ARP MCU days that taught us a lot. We matured a lot as a facility. We've identified vulnerabilities that would have limited SWPF production if we hadn't taken corrective action. The ELOD project, phase 1 was a big success. Phase 2 is in progress right now. I have very high hopes for that. And we do have a couple of residual risks that we acknowledge, but we have a very good plan to proactively address them, and I believe we're going to be in a great position to support SWPF moving forward. Now, I know necessarily covering that much material, that was a fairly high level of detail. If you guys have specific questions that I haven't addressed in my talk, I'd welcome them.
All right. Who's going to start us off? Gil.
Going back to slide 12.
Microphone.
So, yeah, I got it. Gil, Cap, slide 12. How much does it cost to do the, it must have, I'm on the wrong slide. Let's see. I guess, going back to 10. I wrote
10, okay.
10 and to, how much is going to be the cost difference to change that up?
Oh, okay. So, I know the non-labor number better than I know the labor number. Mark would know what three weeks of maintenance time costs, but it's pretty substantially different. These paddles, as received from the manufacturer, I think are about $15,000 a piece, so they're fairly expensive. So when you talk about changing 12 of them, you can be a couple $100,000 relatively quickly. The effort that we've done with the lab over the past 2 fiscal years to develop these and produce the first set of paddles, I think is a total of about $650,000. However, a lot of that was in developing the jigs and the programming within the machine shop to be able to allow them to cut these geometries. I'm waiting for an estimate on what just tips are going to cost me, but I would expect it to go from hundreds $1,000 number to tens $1,000 number to do that overhaul.
Thanks.
Carl?
Carl Steen, cab. When the end product, the slurry or grout that goes out through your process and into the SDU, it's a kind of a hard question, how hard does that become, the end product, and then how corrosive is it by the time everything is done?
Okay. You would have a difficult time if you were to come out to the facility and look at the product. You would have a difficult time discerning it from structural concrete. We do not require compressive strength testing as part of any sort of performance requirement. The performance of the product is not really tied to its compressive strength, but we have history of testing that. Compressive strength of saltstone exceeds 5,000 pounds. So it is a very robust waste form.
Is it very corrosive?
Oh, no, it is not corrosive. It is alkaline, like all cementitious products are, but no, it's not corrosive. Other questions?
Cementitious?
Cementitious.
That's a new word for me.
Bearing cement is cementitious.
Cementitious. Okay, cool. Jerry?
Jerry Mossbarger, cab. On slide 3, you put something called a clean cap batch tank, but you didn't mention that.
I did not mention the clean cap batch tank because fortunately, SWPF is going to make the clean cap batch tank irrelevant, but I should have spoken to it. When we were processing saltstone into Vault 4 in the mid-2000s, as I said, there was a couple of years where we were processing material with a higher curie content. And there was a concern from a rad protection standpoint because the cells in Vault 4 were very large. They were 100 feet by 100 feet, and you had 12 of them. So you had this very large plane, and there was concern about sky shine of gamma coming up and then back down to the facility workers. And so what we would do is when we were going to transition from an active cell and move over to a new cell, we would actually pour a layer of clean, non-radioactive grout to act as a shield to reduce overall worker exposure. And we simply had a dedicated tank within the facility that provided that water supply. But it simply used inhibited water of pH 11-ish as opposed to the salt solution, which has a pH of over 13. But that is not required because of how highly decontaminated the waste will be coming from SWPF, so we won't have to use that part of the facility.
Bob?
Bob Smith, cab. I'm assuming that your foreign materials that are included have a slightly different, or if not significant different density than your solution, your salt solution.
Yes, that is correct. They're heavier.
Have you thought about using a hydroclone or a strainer in front of the pumps to catch the foreign material?
We have, and there has been, I would say, a spirited debate over the years whether using strainers aren't more trouble than they're worth because of the servicing associated with them. We had used some strainers on a temporary basis before we were able to get the magnetic separators developed and deployed into the field. Since we've gotten the separators installed, we've tried to go away from the use of strainers because of the pluggage risks they can cause to other equipment while we operate.
Hydroclones can be very effective, though.
Correct, but again, if I wasn't clear, the foreign material is not coming from handling the dry solids.
No, from the chocolate milk.
Okay, the unfortunate part is there's no foreign material coming with our liquid feeds. The foreign material is only associated with the receipt of the dry material.
Understand, but
Okay.
then once you mix it, getting into the pump is where the most significant risk of outage is it not?
Okay, no, I understand what you're talking about. I can say we have not assessed that, but now that I've heard it, I'm going to take it home and we'll talk about that. So you mean at the discharge of the mixer upstream of the pump?
Right, it's
Okay.
the same thing as a cyclone, except instead of a gas, you've got a liquid passing through it.
No, I understand your question. We have not
It's-
assessed that.
Change in velocity and residence time. Thank you.
Thanks, Bob. Dave?
Dave Lavagas, Cap, thank you for an excellent presentation. Back on slide 10, the tips that if the new design proves to be successful, are they the only thing that ever wears out? You don't expect that you'll ever have to tear this thing down again?
Oh gosh, you're never going to get me to say never, but those have by far been our highest wear component. There are other things in the drivetrain. There are, we have bearings and seals, but I can't recall. I'm trying to think. So we've to date on that mixer probably put about 7 million gallons through it, which is a fair fraction of the overall mission that we're charged to go do. And I don't think we've had to replace anything except paddles. So there may be an occasion or two in the facility life cycle where we need to go touch some of those other components, but by and large, no, they're pretty robust.
Thank you.
So the end product is grout that's going to be then go into a stable environment for X years for decay of whatever minor radioactivity is in there, A, and B, stabilizing the chemicals. What is X? What is the goal is to stabilize it for, what is X years?
So it depends. We generally look at two different things. One is on the state side, we've got to produce a non-hazardous waste. And so I don't think we talk about that in terms of X years. I think that's just we've got to demonstrate acceptable leachability at the time of production. But stabilization of heavy metals, so mercury, lead, cadmium, all the things that you test for in T-clip is one of the things from a performance perspective. Radiological performance, and we talked this morning about doing a radiological performance assessment, is also a key because we have a threshold of the total annual dose that this facility can give to a future farmer in the area. But I can't recall if that period of performance is 1,000 years or 10,000 years. But it's on the thousands of years time frame. I want to say that 435.1 requires 1,000, but you have to assess beyond that.
So the assumption is that the structure that this is put into, i.e. the concrete structure, is going to maintain integrity for 1,000 years?
The performance assessment has a lot of assumptions about degradation, and it does not assess only the waste form. It assesses what is effectively a disposal system. So it uses site-specific hydrogeology. It uses assumptions on the construction of the disposal unit itself. It has an assumed closure cap that we obviously have yet to install. And all of those things are modeled to degrade, but they're going to degrade at some rate. So I'd have to have one of the assessment guys here to answer the question. They will tell you that in their model, they are not assuming at year 10,000 it looks exactly like it does today. They do have, informed by industry research and work that we've done with the labs, they do assume some amount of degradation over time. And that's all put through probabilistic modeling.
It would be interesting, maybe we've done this some in the past, but it would be interesting to kind of understand that a little bit.
The
Maybe,
modeling.
yeah, in a future meeting or something to get some info on that, because that is an interesting construct.
Bob, did you have a follow-up?
Yes, Bob Smith, Cap. This seems so simple. I'm sure I probably already know the answer, but I would assume that the wear is taking place on the end away from the drive end of the screws. Is that correct? You're going to have a drive end, you're going to have basically a bearing end to support the shaft.
Yes. Yes.
So could you not switch it so that the wear end is the opposite end from where the wear is taking place? I don't have a great answer to your question.
I suppose there's some potential to do that. This is sort of this is a commercial mixer that we procure with a very high level of quality. So it's not something that's exactly custom for the nuclear industry. We would probably at that point be looking into a pretty wholesale redesign of the equipment itself.
Okay, and then the other thing is some sort of a premix of the liquid and the dry in some sort of a static mixer or something that would possibly start the wetting out of the cake a little bit beforehand before it got in there, so you wouldn't necessarily have as much dry solids contact.
Yes, there's some opportunity there. One of the things, again, if I can find my button, is, and the angle on this is terrible, but the area that we're concerned about is effectively upstream of this pipe and downstream of this guy. And so, yeah, one of the things that we could consider is, can you replumb that to minimize, to make that zone as small as possible? And I would propose, if we do not find success with these next two alternatives, we'll be looking at that.
Thank you.
All right, folks. Any other follow-up from around the table? Yeah, Dan.
Dan Kaminsky, Cab. Just curious, is the location of the mixer in an area that you could do an entire unit swap to reduce your downtime?
Yes, and I did not speak specifically to it because I was in a hurry, but that bullet right there, one of the things we did in phase one of ELAW was went ahead and bought an extra mixer. And the mixer has a variety of pieces to it, and you can't see them all in the photo that I've got here. But out of frame, there is a transmission and motor, and those are split and set apart on different pads. So we can go in and do just a transmission and motor swap, or go do just a mixer body swap, and try to make that do it as quickly as possible.
All right. Anything further? All right. Thank you very much,
Thank
sir.
you, guys. Appreciate that.
Take that from me. All right. Up next, we have Pam Marks with Salt Waste Processing Facility. It's always a great one. Not to build it up too much, but I always like it when you come out. I always like it when you come out and present.
Well, good afternoon, everyone. How are you guys? Nice to be back again. It's actually been a year since I was here talking to you guys. If you recall, I exited stage left and had hip replacement surgery. So I'm back, I'm doing great, and I'm here to tell you SWPF is doing great too. So we're both doing wonderful, and I want to thank you guys for your thoughts and prayers last year. It was very good. Thank you. So I'm here to update you on salt waste processing. I'm going to start with a little bit of a project overview. For those of you who have been on the cab for a while, you've seen this. You've probably heard it several times today already, but I'll just go quickly through a refresher here for those who haven't seen it. So what does salt waste processing facility do? It's going to reduce the radioactive materials that require vitrification. We are the big machine. You've heard that. We're going to do 6 to 9 million gallons a year. Our nominal design capacity is 7.2 million gallons a year. And at the time we start up, we anticipate about 90% of the tank waste volume will be processed through salt waste processing facility. Of course, some of that volume has already been processed through ARPMCU, and some of it's going to be processed through Ticker, but we are the big machine. You've seen this slide probably more than once today already, so I won't spend a lot of time on it. Just a couple of key items right here. Of course, you heard ARPMCU was shut down in June in preparation for the tie-ins with salt waste processing facility. I'm sure Mark already briefed you that that tie-in work is going very, very well, and we will have everything done except the last connection of the pipes by the end of November, waiting on SWPF startup. Ticker was started up in, I think, late spring, and it's functional. So now we are waiting on salt waste processing to get up and running to finish the life cycle. This is our process overview. Again, as you've heard, the material comes in from the F&H tank farms. We have 3 unit operations. The first one is the alpha strike. We use a monosodium titanate to strike the material, and it removes the actinides and the strontium from the material, and that stream goes to DWPF for vitrification. We then move the material into the cesium removal process. We use a solvent extraction process to do that, and that takes out the cesium, and that goes back to DWPF. We have a 3rd unit operation called alpha finishing, and it's there in case the first 2 steps don't work, and we just kind of need to polish the material to meet our waste acceptance criteria. At this point in time, we don't anticipate needing that unit operation in the near term. If we need it at all, it'll probably be toward the end of the life cycle of SWPF when we have some of our more difficult wastes to process. And then once we process through those, it goes to saltstone. You just heard the presentation on the salt disposal facility. And again, I think Mark briefed you on the status of the salt disposal units earlier today. Oops, wrong button. Just an update from last year. I know everybody's always interested in employment in our community, so we're about 480 strong right now. Last year when I was here, it was 460. We added some mostly construction and maintenance craft to deal with some of the operations or the equipment in the facility. And that number, it'll ebb and flow. In the coming months, you'll see it go down to about 460 and probably reduce a little bit more about the time we get into hot operations as we wrap up testing. But we're holding steady around that 400, about 460 number. A lot of our workforce is new people to the nuclear industry, so it's great. We've hired, it's a blend. We have hired some very experienced people from other parts of the site, other parts of the country with strong nuclear experience, but we also have the new workforce coming in, our maintenance workers, our lab personnel. So we're training up and the operators, training up the future of the nuclear industry. So that's really exciting too, to watch them embrace this culture and this work environment. So we're really proud of that. So I'll give you a status of where we are. We went through a series of management self-assessments as we've commissioned the facility. We started back a couple years ago. We had MSA 1, and that was when we came out of construction and we were going to begin water testing. So we did a management self-assessment, and we were looking at some key areas we wanted to make sure were mature enough at the time so we could safely do that testing. And you can see those listed here. Conduct of operations, our engineering programs, maintenance programs, work planning and control, and industrial and safety. So after we finished our water testing, then the next step was to introduce chemicals into the facility. That's where we are right now. We're processing with chemicals. So as we began, entered that phase, we had some other areas that became important, like chemical safety, making sure our personnel were adequately trained to deal with the chemical hazards in the facility. We, of course, then we're going to be generating hazardous waste streams, which needed to be disposed of, and be prepared to safely operate the facility with a chemical simulant that replicates the waste feed that we will get when we become operational. So we've completed that journey, and back toward the end of July, we finished Management Self-Assessment 3. That Management Self-Assessment was to give us a feel of how we were standing relative to starting our Operational Readiness Review. So when we Management Self-Assessment 3, in addition to all these things, focused then on emergency management, implementing our safety basis, and radiation protection. We are in the process right now of resolving the issues that came out of that review, and also completing the implementation of our safety basis. At this point, the next step in the process would be to go into the contractor ORR. Sorry about that, I'll go back. We anticipate that's going to occur this fall. That's the current schedule. We do the contractor operational readiness review, and once they resolve any issues that are identified, then DOE brings in an independent team, and we do our own operational readiness review. And all of those steps lead up to our authorization to operate the facility. Once we become hot, we do have a few other performance tests that we need to do that obviously we can't do without radioactive material. We've got some shielding calculation or measurements we have to do. We have to measure some stack effluents and of course ensure that we're meeting all of our waste acceptance criteria. So what is all this testing about? April of 2016, not doing well here. We completed construction, and I think you recall I talked to you about system turnover. We had 72 individual systems that had to be turned over from construction to the testing organization. Then we went through what we called calibration, grooming, and alignment, and we did operational tests and integrated operational tests. We had 60 individual system tests that we test with water. And again, the purpose of that testing was to make sure all of our components operated, the pumps pumped properly, all of our valves actuated properly, all of our safety instrumentation worked the way it should. So out of those 60 operational tests, we did 5 integrated operational tests. And then at the very last step, we did one major run with water that brought the whole system together. So if you think of it as a pyramid, there were 60 blocks, there were 5 blocks, and then there was 1 block, and kind of build it up from there. Once we convinced ourselves the plant could operate with water adequately, we started what we call cold commissioning. That is the phase we're in right now. We did performance verification testing, and we are currently, as we speak, we started the design capacity performance test last Friday night. That test will run about 10 days, so right around October 1st, we'll finish that, we'll have the results. In the performance testing phase, what we did is we ran, again, each of the systems at some nominal flow rate. So we were able to demonstrate, we ran 21 batches through CZIX, and we were able to demonstrate that they could produce to the design capacity. They ran between 6.9 and 7.3 million gallons for all 21 of them. So the system's very reliable. Now, with the design capacity performance test, we are operating at various levels. We have incentivized our contractor to demonstrate the machine can run at $9.3 million gallons. So that's their goal. It's a graded incentive. If they hit 7.3, which is our design capacity, they earn a certain amount of money. If they hit 8.3, they earn a little bit more, and if they hit 9.3, they earn max fee. So the intent of the department was to make sure that we could demonstrate that this machine met or exceeded its design capacity, and that's where we are right now. And it's going well right now. The other thing we still have to finish up is what we call off-standard tests. There's 5 of those, and those are off normal conditions in the facility. We take out plant power and prove we can bring the facility back up. We take out our control system and prove we can get it back online. We take down our ventilation and demonstrate we can start it up. So there's 5 of those tests. 2 have been done, so we still have 3 that'll need to be completed after DCPT. Then, as I've mentioned, we do the ORRs and hot commissioning and then into normal operations. So, what's next? Finish cold commissioning and get authorization to operate the facility. Sounds simple, right? But there's a lot in that. Again, a lot more testing to do. We're still working on getting our emergency preparedness program where we want. We're working with our staff to make sure that we get proficient in radiological proficiency and conduct of operations. So a lot of it, again, is because we have a young staff. They're eager. Every review team we have that comes in talks about how great the staff is, how much they want to learn, how excited they are to be part of salt waste processing. So, of course, that makes the rest of it easy. We just have to work with them and make sure. It's like, I use the analogy when your child first got their driver's license, right? It took a while. They passed the test, but I don't know about you, but it took my dad a year to give me the car key. So it takes a while, and you have to make sure they can do it safely. So that's where we are. We're still anticipating doing the operational readiness review the end of this year, or probably early in January. And just a reminder that my commitment to the Secretary of Energy was we would finish before January 31st at less than $2.3 billion, and I am on track to do that. So, any questions?
Let's go. Questions for Pam? Jerry.
Jerry Mossbarger, Cab. I just have a curious question, I guess.
Sure.
When you showed your staffing on that one slide, you had one category called craft. You showed about maybe 60 employees that are craft. What
Yeah,
is craft?
that's the union craft, the union labor. Those are the
Oh.
mechanics, electricians, people like that. Yeah. Differentiating them from our maintenance workforce.
Oh, Doug.
Great presentation,
Thank you.
Pam. On your slide 8, during your testing phases there at the your water testing phase and going
Which slide number are you referring to?
slide number 8.
Okay. Is she going back or do I need to do that? This one? Mhm.
Yes.
Yeah.
Yeah. During your water testing phase and then going into your chemical phase testing, do you use the same personnel for those testing phases?
Absolutely.
Okay. So throughout that whole testing of that MSA all the way through, all the same personnel were used for
Yes,
that?
sir. Yeah,
Okay.
it's part of their maturing and learning the systems. Yes, all the same people.
Great. Thank you.
Malcolm.
Good presentation. By the way, as you went through the testing to date and your corrective action program that y'all have that identifies problems and tries to understand what the root causes of them are and so forth, of the major problems that y'all identified during this testing phase, were most of them personnel versus facility? Because you scaled up from a facility already that was in place
Yes.
to this facility, so I would assume they were personnel, but did you find scaling a problem as well?
They weren't scaling issues. Salt waste project historically has tested all of our major components at full scale even before we went into construction. So, and of course we have the benefits of ARP-MCU. So they weren't any major system issues. I will say we had some nuisance issues like getting some of our pumps to run and some of our control indicators, some of those kind of things. But having done these kind of startups before, that's the good news. You can work through those little problems, but and then the rest were, yes, it's more again the maturing workforce, getting them knowledgeable in how to operate in a nuclear environment, conduct of ops issues, some RADCON issues, things like that.
In that regard, do you find the culture of the workforce to be positive at this juncture? You alluded to the fact that it was, but
Yeah, like I said, we see it. Every review team that we have come in accolades our workforce and their positive attitude, their work ethic. We did a external safety culture work environment review 2 years ago now, I think. And again, good positive feedback from that the workforce was maturing and they had a great attitude. And our turnover has actually been pretty good. I mean, when I say good, it's been fairly low. We've had some challenges in the laboratory area because we are a 24/7 operation and they can get better high-paying jobs working day shift in other locations. So we've had a little bit more turnover there, but our maintenance crew, our operations, we're down at around the 4% turnover level, which is for the nuclear industry these days is really, really good. So you can see that the people are happy working on the project. And of course they see a future. We're going to be running for 10 to 15 years, so they have good job security. So that's important too.
is that different by comparison to other sections of the workforce within the site complex, or do you think that's kind of symbolic of all the?
I think across the board we have a very motivated and positive workforce. I don't deal directly with some of the other contractors, but I don't hear any issues. I think we have a really good work environment at the Savannah River site, and we work hard to keep it that way.
Thank you.
All right. Any other questions for Pam? Dave?
Dave Babakis, CAP. Thank you for the excellent presentation. I was just looking back at some notes, and at one point you had some issues with a contractor, lack of confidence in the ability to forecast the project's future milestones and costs, and you said the schedule remained unstable and unreliable, but now you're saying you're back on track. Have there been any other problems with this contractor, or has everything been worked out?
No, we've been working with them to resolve those issues. Of course, as you get toward the end, you can't have a lot of variability, and it is a very dynamic environment. When you're a few months from the end, one small issue, of course, it's day for day pretty much. But we've been working closely with them on those issues, all the way to the headquarter level.
Okay. Gil.
Thanks, Pam. I appreciate it. Everybody, you may not know, Pam was one of our DDFOs for a year, so it's always fun to see her come back. And Pam, I have one question. So January 31st, what are you going to be doing? Because this has been as long as I've known you, this has been yours. So
It's been mine for the last 6 years, and it's been a very gratifying experience. I've told a lot of people this is what I came to do, and I'm going to see it through. But there's a lot of exciting things out there. You hear about them every day. We're doing great stuff around the Savannah River site. We love living in Aiken, and I know that there's the right thing out there for me. So I'm not going to decide till the time comes.
Fair enough.
I'm staying focused on this. That's all I worry about these days. I think my husband can attest to that.
All right.
Thank you.
Any last parting questions for Pam? Thank you very much.
Thank you.
Hyper efficient presenter. Just absolutely dynamic. I love it. Hyper efficient. So before we progress on, I think Aaron White, you had a few things that you wanted to talk to. If you'll step up to the public comment microphone over here, we'll get your comments in. After Aaron goes, we're going to take a short break and then come back, okay?
Yes, good afternoon. This is just a little bit of a clarification from the Saltstone presentation. There was some discussion regarding the performance or the compliance period for the saltstone disposal facility or the saltstone disposal units. The compliance period that we model to according to our DOE regulations is 1,000 years. We do look to be informed up to peak dose, which basically means that we want to have assurances that we meet all of our performance objectives within the first 1,000-year period, but we also want to know what's going on post that 1,000 years up until when the max amount of dose could be associated to a hypothetical member of the public. Member of the public.
Thank you very much, Aaron. So let's do this. Let's take 15 because the restrooms are spread out all over the building and none of them are close to here. Let's come back at 2 o'clock and be back in our seats. 2 o'clock, please. We're going to bring it back in. This is the same one that you used in May. Let's find our seats, everyone. Let's bring it back in. Let's get started. Kim's ready. Get everybody else ready. So we got just a little bit more left today. We've got a great ticker presentation coming up. We'll go into a FOC overview, which many of you not had the chance to hear yet. So I'm really excited for you to see that. Afterwards, we've got some voting that we need to take care of and some public comments to do today, and then we'll set you free. So let's start things off with a ticker presentation with Jeff Bentley and Penn Mason. Thank you, gentlemen.
See, on? Okay. All right. I'm Jeff Bentley. I'm a program manager with the Department of Energy. I'm here today with Mr. Penn Mason. He's a senior project manager for our contractor Savannah River remediation. Specifically, he's the project manager for the tank closure cesium removal project, otherwise known as TICKR. I believe we spoke to you back in May and gave you a little bit of an update on how things were progressing. We had started operating. Today we just wanted to come in and give you a further update on what's been happening. I'm going to start things off. We're going to, one more time, we're going to take a look at that liquid waste system overview sheet. Won't spend very long on there, I promise. Then I'm going to go through the conceptual flow sheet that we have for TICKR. I covered that last time in May, but we want to do it one more time. After that, I'm going to turn it over to Mr. Mason, who's going to talk a little about the ups and downs and the achievements and things that we've had during the operation of the unit, as well as, I think it was mentioned earlier, the failure of the transfer/recirculation pump in tank 10. He'll go over a little bit of that and our path forward. Following that, we're going to come back to me, and I'll hit on some of the upcoming milestones that we have on the regulatory side, specific to both TICKR itself, as well as the tanks that are associated with providing the feed. All right, liquid waste program. I am only going to talk about this unit right over here, okay, the TCCR. I wanted to mention one thing about this system, and that is if you take a look at all the other facilities in the liquid waste system, they're all integrated. They all depend on each other to operate, okay? TICKR is a sort of an island. It's out there on its own. We don't need DWPF operating to process material through TICKR. In fact, even though you see a line here, we really don't even need saltstone operating for us to operate TICKR. What we do need is space. And as long as we have space, and there's two different tanks that we're looking at, in our tank 11 or our tank 50, as long as we have space in those tanks, TICKR can go. Which brings me over to the conceptual flow sheet. We start, the demonstration that we've done this year, that we started back in January, is using the material, the salt cake that was in tank 10. So we had to add liquid to tank 10 and dissolve up a salt and create a batch that we could then send through the unit. What happens is after we get it all dissolved and ready, we pump it up. This is the ticker unit itself. It goes into that unit. It flows through columns that are filled with an ion exchange resin that absorbs the cesium out of that waste stream. Coming out the back end is a decontaminated salt solution, so a stream that's had the cesium removed. That can then get sampled here in tank 11, and we'll verify that it does indeed meet the acceptance criteria for the saltstone facility. And once it does, we'll pump it on over to tank 50, which is our dedicated feed tank for that facility. The other aspect of ticker here is what I just mentioned, the columns inside that are filled with the ion exchange resin. As the material goes through it, as I said, the cesium absorbs that resin, eventually taking up all the spots that it can take up. When it reaches its capacity, we call that column spent. So we take these, once it's full, we take these spent columns, we actually remove them from the unit and transport them over to a safe storage location. We call it the interim safe storage. And after we do that, we'll put in 2 fresh columns. Those are 2 new columns with unused CST resin. Let's see. All right, and with that, I'm going to let Penn talk to you a little bit about the batches that we've processed thus far.
Okay. All right. I think we're up and running now. Okay. Thanks, everybody. Again, allowing for both Jeff and I to come address the group here, and I'll take you through where we stand going through our operations batches. I'm going to talk from back here so I can look at the slide while I talk to you. But I'm going to start with the site map over here. And Jeff took you through the process diagram. This is the site map. You notice the 4-pack of tanks, 9, 10, 11, and 12. Tank 10, as Jeff pointed out, is our feed tank. And that is where we dissolve the salt in the tank using these 3 recirculating lines that go out from the centerizer. Oops, wrong slide. And then we feed up north to the ticker unit, which is right up here, and then we drop down our DSS to tank 11 right here. I'll also point the vicinity of tank 9, which is our next tank. Jeff's going to talk about that in just a minute. And I also want to point out a couple other things about this tank. Number one, on tank 10 here, there are no mixer pumps. So we're using this recirculating transfer pump that Jeff pointed out to do both salt dissolution and feeding ticker. And so there's a lot of business going on in this one tank. We both dissolve, we qualify ticker batches, and we feed ticker. So moving on to the narrative over on the right side over here. Again, this is just a very, very brief summary, but we started batch 1 salt dissolution back in November. We actually started processing ticker in January. We've processed 2 batches, about 210,000 gallons. And we've been successful with those 2 batches. Unfortunately, on August the 8th is when our transfer pump failed. And since then, we haven't been able to run ticker. We'll talk more about that as we get back towards the slides. Okay, so batch 1, first of all, and we presented batch 1 to CAB here 3 months ago, so I'll go a little quicker through our batch 1. But we started with 150,000 gallons of water add into the tank. We then recirculated, we sampled, and qualified. Now, over on the right-hand side, you see a picture of our qualification sample vial. And what we do is we take a small amount of CST, crystalline silicotitanate. You heard Mark talk about the ion exchange resin this morning. That is the silicon crystal CST. and you put it in this mesh vial and then into this larger container. You can see veins cut in either side. We call this a tea bag. It allows for the CST to contact the salt cake in the tank, or the dissolved salt, and then you actually use that to qualify your tank. We did that. Our DSA requires that we achieve 3.2 molar sodium. We did not achieve that for batch 1, and so we had to remediate the tank with about 16,000 gallons of sodium hydroxide. Once we did that, resampled, achieved our qualification goals and our sodium molarity, we then were able to process, starting in January, we processed 152,000 gallons of salt, dissolved salt. Unfortunately, you've heard us talk about this. We realized that we had a Burkite layer in the tank. As Mark stated this morning, there had been some previous campaigns. They basically got the easy salt out and we left the Burkite layer. We talked about this Burkite layer 3 months ago. It is basically a very, very hard, dissolvable, but a very, very difficult to dissolve layer of salt waste. On to batch 2. We moved into batch 2. We now modified our plan and our strategy to go forward based on our experiences with tank 4, where we actually showed or had Burkite in that tank. So we went to smaller batch sizes, more recirculation, smaller batch size. So we put in 2 25,000 gallon water adds, a total of 50,000 gallons, recirculated in between. One measurement of solubility is your density increases. So as you get more salt dissolved into your solution there, your density goes up. And so you can see this chart here. It looks like it's a little hard to read from the back, but time on the horizontal, density going up the vertical, and you can see this slow, gradual, almost arithmetic relationship for a total of about 65 days that we actually had to dissolve salt. And so we were able to do that, and we processed batch 2 in June, roughly about 58,000 gallons. Before we started batch 3, we made the decision to hydrolance the tank, and you may have heard of this, but this is a technique that we use to break up heels and stuff. So what we do is we take this long wand, and we put what we call a pineapple head at the bottom of it. It's about as big as your fist, and it's got different types of high pressure nozzles that point in different directions. So when you put it in the tank, it just shoots out all different ways. And we were able to put it in the tank, in the center riser next to the transfer pump, stick it down through the Burkite, and took it almost all the way down to the tank, the bottom of the tank. We didn't go through the bottom of the tank, we went almost to the bottom of the tank. And so we were able to get through the Burkite very easily. That hydrolancing seemed to work very, very well. So after hydrolancing, we started our recirculation on or about July 16th. We circulated, about, again, we added 50,000, keep hitting this button here. We added 50,000 gallons, continued recirculated for 21 days, and on the 21st day is when we had our pump failure. And that pump had reached its service life in a radiation environment, which is about 3,000 hours. So that was our plan, but unfortunately we were dissolving salt instead of processing ticker. So the pump lasted the life that it was intended to last. However, we spent more time dissolving salt than we did processing. The picture that you see on the right-hand side here, this is the actual transfer pump at the bottom of a mast with a plate that immerses in the riser. Kind of hard to see here, but this indicates what a riser looks like. this being inside the tank right here. And that ledge that you see right there is this ledge. It sits on the ledge inside the riser. On the top of this transfer pump, you've got a three-way valve and a manifold with 4 hoses coming into this tank. 3 of those hoses are used for recirculation. 1 of those hoses is used to transfer. You can't do both operations at the same time. It's one or the other. So, what's our path forward? First of all, we've recognized that the current approach with the recirculating pump is inadequate for what we're trying to do. It would have been great if the salt had been easy to dissolve, but the Burkite layer was a very difficult, and we need more energy in the tank. We need more mixing, we need more energy in the tank. So it's inadequate to do, it's reached the limits of its effectiveness. We need a new technical approach to make sure that we can go after this Burkite in the tank. We plan to replace the transfer pump in kind, a few little modifications to it. We're going to add 2 CSMPs, commercial submersible mixer pumps. These are commonly used in the tank farm. We use them for heel removal on most applications in all of our tanks. It is a common tool that we use to actually remove the heel out of all of our closure tanks. In this case, we're doing 2 things. Not only are we removing the heel, but as your heel reduces, you're creating more qualification space for the Tank 9 material to come over to the tank. So one thing you want to do, you want to create as much qualification space in this tank, so when we prepare for Tank 9, which has more salt in it than Tank 10, by the time we dissolve the salt in Tank 9, we're looking at about 2.4 million gallons of dissolved salt. So we're trying to create as much qualification space in this tank as we can. So what we intend to do and what we are placing forward and pursuing is the fact that we're going to claim BWR complete, bulk waste removal efforts complete. Mark talked about bulk waste removal efforts this morning on Tank 10. We're going to focus all our energy on getting Tank 9 ready and the materials brought over to Tank 10 so we can start hitting that and processing that material through Tank 9 and through Ticker. And in doing that, of course, we want to, as I said, work this heel down here so we gain more qualification space. That should be fewer batches. We do want to process the remaining material that we have. Remember, we have about 50,000 gallons left in the tank. We want to go ahead and process that to gain technical understanding and operational data so we can optimize our Ticker operating plan for Tank 9 materials. The pictures that you see over here to the right, this top picture is the center riser, that plate. Okay. The plate you see is the top plate on the top of the tank. You can see these black hose and hose transfer lines. As I said, there are 4 of them. This is before all the shielding has been put on it. These 2 pictures at the bottom, all the yellow that you see there is all the shielding that has been placed over that transfer line. So it's going to be quite an effort to change that transfer pump out. You got to roll all the shielding back, you got to roll the hoses back, pull the pump out, and move, and then go pull the pump out. We're going to hydrolance again, new pump, then we got to put all the shielding back. So quite a bit of work to go do this, but it's the right thing to go do. This view right here is an isometric of Tank 10. It shows the transfer pump in the center riser, 3-way valve right there coming to a manifold on the left here, and then 3 recirculating lines and the transfer line going over to Ticker. So that isometric kind of gives you a better view of what's going on in Tank 10. I think that's it for my slides. So Jeff, I'll go back to you and remain if anybody has any questions.
So looking ahead, The first commitment we have coming up is with the state of South Carolina. It's under the Salt Dispute Resolution Agreement, and it pertains to the ticker unit itself. We agreed to deliver an evaluation report on the technical and economic, I think it's the feasibility and efficiency of the ticker and applying it to a second tank. That report is it's being finalized pretty much as we speak. It's being worked on. The contractor's about to have the final version released and through an external review process, and we'll be delivering it to the state by the end of this week. Going after that, we have the Tank 10 bulk waste removal efforts complete milestone. That's under the Federal Facilities Agreement. So that agreement is in concert with not only the state of South Carolina, but also the Environmental Protection Agency. That one's due in the end of November. We were working the arguments as to why we've reached bulk waste removal complete in Tank 10. Right now, we've nearly got our presentation complete and finalized, and more than likely, we will be delivering that to those two parties sometime mid-October timeframe. After that, we have a commitment that was recently agreed to begin our bulk waste removal efforts over in Tank 9, which is obviously our next tank that we're going to treat through ticker. That is set for September of next year for us to actually add the bulk, basically the first big water addition to start dissolving the salt in Tank 9. We're actually on track to beat that quite considerably. I think, correct me if I'm wrong, isn't it somewhere like around March, April timeframe that we're tracking? Yes.
It's
So
a little bit later.
we're well ahead of that September date for that particular milestone. And speaking of Tank 9 being the next tank through, and this is the new conceptual flow sheet for you. It shouldn't look too different than the one I gave you previously in the presentation. The only thing new here is that we're connecting Tank 9 to Tank 10, right, to dissolve salt in 9 and transfer it over to 10, where we can accumulate a big batch, get it qualified, and dedicate 10 as a feed tank to ticker as we do to Tank 9 material. And that's it. The ticker unit itself, that whole process is staying the same. So in other words, there's just no more differences. Going forward after this, we have, as Penn mentioned, we're replacing that transfer/recirculation pump in Tank 10. It was an unfortunate incident that we lost that pump. It really has no bearing though on where we stand, as far as we had realized that our current method of dissolving the salt was just not efficient. He showed you the graph of how long it took. We had to recirc for over 60 days just to get that second batch, and to a point that it was qualified to feed to the ticker. The initial plans were that it was going to be about 10 days of recirculation. Not only that, it was going to be 10 days of recirculation, but it was going to be 10 days of a batch that size of about 150,000 gallons. So we had the third of a size taking 6 times the amount of time to dissolve and get prepared. Just wasn't working, as we realized we needed a new technology going forward in order to address that, which brings us up to the fact that we're also going to add a couple CSMPs to Tank 9 and use that method to try to remove this heel as we process, Tank 10, to remove that heel in Tank 10 as we process Tank 9. We're working on Tank 9 quite diligently. We've got it broken up into 2 different phases. One is the ticker phase for Tank 9, and then the other one is the salt dissolution phase for tank 9. Over on the ticker side, we've got procurements at different stages for new pre-filters that will go into the ticker unit, new ion exchange columns, because obviously we have 4. These are the 4 that were procured just for the tank 10 demonstration. We're going to need about 16 more to do tank 9, so we have to go procure those. Plus we have to procure the new resin that's going to go inside those columns. And like I said, all 3 of those procurements are working. They're at different stages right now. We have to expand that interim safe storage facility. It's got space right now for just the initial 4 columns. So that is that's in the design phase right now, where we got to go back, and because we have new material that we're going to process through TCCR, we have to go back and analyze our safety basis for that new material, okay, since it has not been analyzed yet. So that's all in process right now. We're doing a DSA review, look and see how much exactly has to be changed. And then on the other side, on the salt dissolution side, they're currently trying to construct the hose and hose transfer lines that will go from 9 to 10. Right now, they're in the middle of removing old equipment from the risers on tank 9, where we're going to install the transfer lines and then bring over to 10. And then ultimately, going forward, this one's a little bit further out, but we have a potential future project which would be ticker unit number 2. So, based upon how we perform going forward with tank 9, we will do a feasibility study based upon that data and determine whether or not it's feasible for us to go and build a second unit. We would locate that unit in F Tank Farm. Here's this little picture on the side. It just shows you where a possible location where I think we're kind of leaning that we would actually put it over by those initial 8 tanks, 1 through 8. This is, once again, if it's feasible to do so, okay, don't want to get ahead of myself, but if it's feasible to do so, we have another milestone commitment to the state that says we will deliver a processing plan for that particular unit number 2 by May of 2022. Okay, so we have almost 3 years, right, till we have that one would come due. And I think with that, we're ready to open it up for questions.
Narendra, let's start with you, being the chair.
Narendra Malakab. In your last presentation, I thought you were going to submit a recommendation that you need a ticker for F-tank form. And we were holding that recommendation because we wanted to hear from you today about some cost and economic analysis, which we haven't heard it. So I don't know why that information is not provided today.
We have 2 different deliverables to the state, 2 different milestones relating to the feasibility of ticker. The first one, which is due next Monday, is a study that looks at it. Is it feasible for us to go and take our current unit, ticker unit number 1, and apply it to the contents of another tank? Okay, so that's the one that we are delivering this week. The second piece of that is, and it's in the future, okay, I mentioned that we have a due date for a processing plan for a second unit if it's determined feasible by May of 2022, okay? So we have to do a feasibility study that looks at, is it worthwhile to go build the second unit in F Tank Farm and have that all done, and if it is so, have the processing plan done by May of 2022. 22. So it's just a little bit different. There's some different pieces in each one. Yeah, I know you're talking about the harder data as far as the cost and everything. That will be part of that feasibility study for the ticker unit number 2. There's going to be there is a little bit of an analysis based upon what we have and what we can compare to in some of the other applications for salt treatment with this first study, which we have indeed said, yes, it is feasible for us to go and apply ticker unit number 1 to tank 9. And we are proceeding with that right now.
So it means we should hold on our recommendations till we have further information available to us.
I would hold on to it because we're committed, we are moving on with tank 9. We've promised that we would do it. And as far as a second unit, it's going to be a little bit of time before we get there, right? We need to get tank 9 done so we can get the information we need to make that analysis for building a second unit.
Okay, my other question is, where are you going to store the resin, which you said intern storage at site? Which is it going to be under cover or in a building or open field or where?
So those columns, the columns themselves are in a shield assembly, right, inside the unit. And when we remove those, we remove that entire shield assembly out, leaving the columns inside. We moved that entire unit over to we call it interim safe storage. It's basically a pad with what are those things? Stanchions on that actually connect to those shield assemblies, or they slide down on the shield assemblies, slide down on those stanchions and keep them in place for moving. They are vented. They have HEPA filters. When we disconnect the lines from ticker, we put on a HEPA filter, so everything is still enclosed, and but we can release pressure, not have to worry about a pressure buildup. And they just sit on this pad. There's no building around it. Okay, they just sit on this pad, and they will sit there either till the end of the liquid waste life cycle, where we will, I think it was mentioned earlier that we would sluice this resin out, and it would actually find its way through DWPF and be vitrified with the materials there in the glass, or crossing our fingers someplace in the country gets licensed for, I think what we are looking at is this greater than Class C type waste, and we can characterize it as that and transfer it off site. That's our two options.
I have one more question. Please forgive me, I keep asking these questions. How easy it is to remove the heel from the tank? Is it hard, or can it be dissolved with just slurry pumps, or you need equipment like Mentis to eat it up and then bring it out?
To remove what? I didn't catch. To remove what?
Can you repeat that for me?
Yeah.
How easy it is to remove the heel from the tank?
Oh, the heel.
Dissolve it?
How easy is it to remove the heel?
The heel? Oh, from the tank? At the bottom. you can give their experience.
And you need a Mentis, what you used in tank 18 and 19, to remove the hardened heel.
Yeah, so we need more energy than a Mantis could do. I remember 18 and 19, you're right, we put the Mantis in and we're able to maneuver it around. But in this case, the CSMPs have over 250 horsepower on each motor. They've got a cleaning radius of some 30 feet. So we're going to put 2 CSMPs in the tank. This is the chosen pump that we're using, mixer pump, to actually do heel removal on all of our tanks. So this is not something special that we have chosen for tank 10. We've got a number of CSMPs on order for a number of tanks that are going to be moving into heel removal. What we typically do, what our closure group typically does, is when they move into bulk waste removal nowadays, they'll go ahead and set up the tank, and sometimes even go ahead and install CSMPs, because they know they're going to need the CSMPs for heel removal. So it's more efficient if you install it all at one point while you've got your forces deployed there. So I think the answer to your question is, I do believe the CSMPs will remove the Burkite heel. We know we can dissolve Burkite. We've done it before. It is a difficult layer to dissolve, but we think we can. And under the Burkite, we believe we've got a softer layer. So we just got to get through this first layer and see if we can get to the softer layer. So I do believe we can.
Thank you.
Okay. Doug.
Doug Howard Cap. Great presentation, Jeff and Penn. Refresh my memory on the ticker concept. Did that come from Hanford, or is it vice versa? Are you guys going to help Hanford with the one that they're doing?
Well, it's really based upon
We were first.
Fukushima and what they were able to do with the technology. And we developed, yes, the unit first. Hanford's following us. And we are providing a lot of input, a lot of lessons learned from Ticker to them to incorporate as they move along in their project.
Okay. Now, going back to the Burkite, did you all in any way foretell that you were going to have a problem with it, or is it because you said you have Burkite in other? Is it also in other tanks that you've?
It's not in every tank.
Right.
It's not in, we've experienced one other time.
Gotcha.
And we've closed 8 tanks now, so we're 1 out of 8. How's that? So no, we don't know of presence of Burkite in all of our tanks. It is a hard layer. It is difficult to get through. Some of our other tanks, as I said, we have not experienced that, so we can't uniformly say we're going to hit Burkite on every tank.
Okay. And final question, if the SWPF facility goes as well as they say it's going to go, you're still going to build that additional ticker, or it doesn't really matter?
Well, right now I'm going to say it doesn't really matter how well it goes, right? That's something we have to look at and analyze and do a feasibility, an economic feasibility assessment as well. Is it worthwhile to do it? Or I mean, it'll play into that report. I'm sure how well things go at SWPF and where we're at in as far as meeting those processing rates that Aaron talked about earlier today that are in the dispute resolution agreement. So, I mean, we'll see where we're at. We'll see what the feasibility study says and make the determination from it, but I can't say one way or the other without that information.
Thank you.
Yes, this is Sonny Blanco, Department of Energy. I just want to add to that. At this point, for the System Plan Revision 21, we are assuming that we do 2 ticker units. Obviously, we're still going through the process of evaluating the performance. We are assuming success in proceeding with this technology. It definitely supports and contributes to shortening the life cycle for the liquid waste mission. And in the agreement with the state and the state, we offered a second unit as part of the alternatives for salt waste processing facility. So it remains to be seen how things work out, but we're definitely assume success in this matter as is reflected in revision 21 of the system plan. It does help shortening the life cycle. Having 2 units and 2 million gallons per year for the next 10 years. I mean, we're talking 2 years in the life cycle. So it matters to us, and that's why we have the contractor in collaboration with us, working so hard on making this happen. So we'll see.
Thank you, son.
Dave Isley.
Dave Isley, Cab. Sounds like you guys have had a pretty busy summer with disappointments. I appreciate the update. I've got two questions. First of all, has the lab been helpful in identifying something to help you with this Burkite problem that's compatible with the rest of the process?
I don't know how to answer that.
Well, okay, so we've got the lab on speed dial. We use the lab with just about everything we do. Ticker has been, as we've talked about, a demonstrate project, a research and development, first of a kind. We talked about that. And yes, we have used the lab in every step of the way. And today, the lab is still doing testing for us as we move out of Ticker and move into the second version of Ticker for Tank 9, which Jeff just described. Yes, they have helped us. They've advised us. They haven't run any specific solubility tests on Burkite. They have previously when we had the Burkite in the first tank. And we, of course, been referring back to all of those studies and actually what worked to dissolve that Burkite. And as I stated, the reason that we changed our strategy from 150,000 gallons of water add to much smaller water adds is because of the Burkite. Burkite dissolves under less water, more circulation, and actually low temperatures. So we've tried to affect that also.
Okay, second question. If you go the Ticker 2 route, is that a Ticker 1 plus lessons learned, or are there enough disappointments to have you go revisit whether Ticker 1 was properly addresses the method of doing this?
I know you have plans. So.
Sure, so what are my plans? Okay, we're definitely going to optimize Ticker 2. We have quite a bit of lessons learned that we would like to put into Ticker 2, number one. Plus, as Jeff has already pointed out, we have delivered and we've communicated quite a bit with Hanford as they have built their TISCR project, tank side CZ removal. And I want the payback. So when as they figure out their lessons learned at Hanford, I want to take that and I want to build that into Ticker 2. So the answer is absolutely we plan to do that.
Okay, so I take that to mean that you are satisfied with the performance of Ticker 1 and will basically stay with that whole concept with some enhancements, improvements, lessons learned, whatever you want to call them.
Yeah, I think it's safe to say, from what I've seen, is Ticker itself has performed very well.
Okay.
Okay, our issues are really solely with dissolving salt, preparing a feed for it. That's where our issues have been, and is trying to get the feed ready.
And we're going to apply lessons learned to the feed also.
Yeah.
Thank you.
Just a quick question, Malcolm Phillips Cab. I was a little confused, and maybe y'all kind of talked around it, but I just didn't get it in my head. I didn't wrap my head around it. Mr. Schmitz this morning gave us a talk, and when he was talking about the various resolution methodologies, of course, the major one that we're looking at is the SWPF, and he talked about Ticker in the context of it being almost another option, but it's all in his comment was it's always good to have another option.
Sure.
Well, there's a difference between having an option to use that you proved and going ahead and doing it, and that difference is dollars being spent, obviously. So at what point is this not another option, and what you're going to do, and when should you stop spending the dollars because you've already proved it as an option? Why in the world are you spending dollars then? I mean, based on what he said, I'm trying to understand it.
All right, so first of all, let's just state what the purpose of Ticker is. Okay, it is a supplemental salt processing treatment. Okay, it is It's not designed to be the workhorse, okay? SWPF is going to be your workhorse, but we made an agreement that we would go look at other technologies and develop something that would supplement, okay, SWPF and the rest of our system. As of right now, on the obviously we would like to have more data, more stuff that we can run through Ticker, all right, and we'll get there with Tank 9. But with the preliminary data that we do have right now, the Ticker is comparable to what we expect the cost to be to operate SWPF. It's very, very comparable. So as long as we made that commitment that we're going to try to supplement and do more and more and more, if it isn't cost prohibitive and exceeding, our main treatment path, I don't see any reason to stop.
Sonny Blanco, Department of Energy. And just as Jeff and Penn have described to you, moving forward with the employing Ticker 1 for tank 9 waste will provide us the data that we need as far as proving the viability and cost effectiveness of this technology. So after doing that operation and collecting that data, we will be making the decision if we're going to be moving forward with the Ticker 2 and make that decision. So that's going to be the point, the moment, or the point where that decision will be made. Did we answer your question?
It was just confusing from what Mark had said, Mr. Smith had said earlier. It seemed that you had already proved it, so why are you going to the next step? That was the obvious question, but I'm not going to push it. That's just...
So Mark's here. So the evaluation looks at least 3 different criteria. The first one is on the mechanical operation of the Ticker unit itself. That was a thumbs up. The second criteria was on what we call the decontamination factor, the amount of cesium removed as you go across the ion exchange column. That was a thumbs up. The third criteria is how much cesium you can actually load on any individual column. That is somewhere between neutral to thumbs down, because it did not load nearly as much cesium per column as we would have expected. That's driven by a couple different things. It was fairly low sodium content. It sucked up more calcium than we expected it to do, so there's a lot of chemistry involved in that. We're going to go to higher sodium concentration, higher cesium concentration, and a smaller particle size resin on the next columns that we buy for Ticker. And that will be the real proof in the pudding on whether it's economically viable.
Any other questions? Dave, did you have a follow-up? Oh, okay. Any other questions? Thank you, gentlemen.
It's tough to hear.
All right, so one more presentation to go, and this one is on the Federal Advisory Committee Act. And I really want to talk about what it is, but I'm pretty sure it's in the first couple of slides of Dave's presentation, so I'm not going to steal his thunder. I'm just going to say that for those of you who actually enjoy learning about laws, this is fun. So I really get this one. This is great for me. Dave, middle button is forward. And the bottom.
Wow. Hi, everyone. My name is David Borak. So I work in the DOE headquarters in Washington, D.C., and I'm the designated federal officer for all of the EM site-specific advisory boards, and there's 8 of them. And the goal of this presentation is really to kind of walk you through the whole program, see that you are a part of a larger group of advisory boards in the federal government, and why we do things like public comment, and why we have things posted to the internet, and all those things are because of the Federal Advisory Committee Act. I'm going to talk a little bit about it. We're going to talk a little bit about how the board got started, some of the guiding principles, some legal considerations, some responsibilities that DOE has and that you all have. Talk about conflicts of interest and take questions, and there might be a quiz if there are no questions. So think of good questions. I keep hitting the wrong button, James. Our boards were chartered in 1994 as a result of a recommendation that DOE got from a group called the Federal Facilities Environmental Restoration Dialogue Committee. And they recommended that EM specifically reach out to the communities surrounding our nuclear sites and form these advisory boards to provide them with advice and recommendations on their cleanup. We have one charter for all of our boards, so we're all actually considered one board, even though there are 8 boards currently right now. We've had as many as 13 advisory boards. Sites that you'll hear the names of, like Rocky Flats, where EM is no longer doing any cleanup, they had an advisory board, and once EM is done, the advisory board kind of goes away. So we have 8 left, and you're one of 8. We are rather unique among advisory boards in the federal government. A lot of different agencies have community advisory boards, but they all seem to be individually chartered. So each advisory board has its own charter and its own thing. They don't really interact with the other boards. Our boards encourage. We have the chair and vice chair of the board come and meet together in a national meeting every year. And it's kind of a unique thing. Oops. So, what is the purpose of the Federal Advisory Committee Act that I keep talking about? So, the Federal Advisory Committee Act was signed into law by President Nixon in 1972, but it was not the first advisory board that the federal government had. So the first advisory board was actually under President Washington in 1794 during something called the Whiskey Rebellion. I'm kind of a history buff, and so I looked into it. It's very interesting. There was a group of farmers. Basically, we had our newly formed country, and the first thing we did after complaining about the British taxing us was to start taxing whiskey and all alcohol in our country. So the farmers in western Pennsylvania got angry and started to gather some revolutionary generals and kind of form a rebellion. And George Washington formed an ad hoc committee of commissioners to kind of advise him on what he should do next, and he actually sent in troops to kind of quell the rebellion. What they should have done is done what the people in Kentucky did, which was just say, come and find us. And they got away with not paying taxes because nobody knew where they were. But anyway, I don't know what happened at this advisory committee that President Washington had, because there was no Federal Advisory Committee Act. So the Federal Advisory Committee Act, what it said was if you're going to form these advisory committees, they need to be in the public eye. Meetings need to be made public. The minutes from those meetings need to be public. Who the members are need to be public. And so all that information is seen by everyone. Before FACA got passed, advisory committees often met in secret. There was no knowledge by the public of who was on those committees. And these are people who are really advising the government on policies. And the FACA contends that folks have a right to know who's doing that. And so kind of that's where it all started. And the idea is to lend credibility and provide transparency into what the government is doing. So this is just an idea of how many FACA boards are out there right now. There's about 1,000 committees right now, 65,000 members. You can read the numbers up there. So just to give you an idea of we are not actually even one board. We are 1/8 of one board meeting here. But there's a lot of boards meeting throughout the government right now. And this is how they're all managed. So one of the things that FACA did was through the GSA, the General Services Administration, it formed one group in the federal government who's in charge of all of these advisory boards. So they keep track of every single member of every single board, every single recommendation that's done. They have something called the FACA database, which is a public database of all this information that goes out there. Every year we have to update it with all of our SSAB information, and it's pretty amazing that they're able to keep track of all this. Each agency has what's called a CMO, a committee management officer, who's in charge of all the different advisory boards that the agency has. So the Department of Energy has about 15 or so advisory boards in it, and the CMO is responsible for all of those advisory boards. Each advisory board has a DFO, which is me for this one, and who is responsible for the work that committee does. Now, I mentioned our board is rather unique. It is. Most boards don't have what we call DDFOs, which are deputy designated federal officers. Those of you who know Michael Michelanis, you'll know that in no way is Michael my deputy in any way. I've actually learned a lot from Michael throughout my career. But what the DDFO designation does is it gives Michael full powers and responsibilities of a DFO. So this way I don't have to travel to every board meeting around the country. So that's just, the DFO and the DDFO are essentially the same thing. Then we also have on our boards, we have the federal coordinators and the local board staff, and these are all folks who kind of contribute to the management of our boards. Then we have you all. Each board has a chair and a vice chair. And the chair and vice chair are responsible for acting as a point of contact for CAB members, for kind of running the meeting, calling votes. And they also serve, as I mentioned, as on the national committee meeting that we have of the chairs and vice chairs. And then we have members, and then we have liaisons to the board. You can have people from the state, you can have people from EPA on your boards. Nevada, their site-specific advisory board has local government officials as liaisons to their board. We've had tribal members as liaisons. So a liaison is just anyone who comes to your meeting and participates but doesn't get a vote in recommendations. So what are the legal requirements of FACA? There's not actually that many, which is surprising to a lot of people. It's a pretty simplistic law. So whenever someone says, oh yeah, I think that board is violating FACA, generally they're not violating FACA. What they're doing is violating some of their operating procedures, but those are very different from the law that is the Federal Advisory Committee Act. So the one thing that every board needs is a charter. I'll go into our charter a little bit later, but a charter is a pretty simple document. It's about a page and a half long. It goes through what the board is responsible, about how many members are on that board, and kind of how often the board meets and when it would need to be renewed. Each charter needs to be renewed in the federal government every 2 years, and the agency is supposed to take a look and say whether or not it really needs to continue having that board. Our charter has been renewed every 2 years since 1994. Meetings have to be open and accessible to the public. They need to be accessible to disabled folks, to anyone who wants to have access to that meeting. They should be able to have access. This includes teleconferences. If we have a teleconference that everyone gets together on a phone call, the public has to have a way to call in for that number. Basically, anytime you're deliberating on a recommendation that you're going to provide to the federal government, the public has a right to hear what you're saying. There are meetings that we don't open generally to the general public. FACA allows for something called administrative meetings, which is meetings that you're not voting on anything, you're just getting information or talking about when your next board meeting is going to be and where it's going to be. Those generally don't have to be open to the public. They're not closed meetings. FACA does allow for closed meetings for national security issues, things like that, but they are meetings where you don't have to have public comment, you don't have to have it recorded, you don't have to do any of those things. The general thing to follow for whether or not a meeting needs to be open or closed is if you have a quorum of members. So if you don't have a quorum of members, then it's like at a subcommittee meeting. Those meetings don't need to be open to the public. I would say because we are a a board representing the public around our sites. If the public wants to come to a subcommittee meeting, they should be allowed to come to that meeting, but that's sort of a management decision at the site level. We have to make sure that our members are fair and balanced in our board. This term is not defined in FACA. What it generally says is we need to have a balance of interests so that we are getting recommendations from groups of people from all across the spectrum. Because our boards are representing the public around our sites, what we try to do is have a geographic balance. We have a balance of men and women. We have a balance of ethnicities, because we're supposed to represent the community around our sites, so our board should look like the community around our sites. But there's no way to really have a fully balanced board. And we try and strive for balance, but I always say that balance is not something you can attain. You just have to keep trying. So if a board is, when we look at our board every year, we generally try to look at new members and think like, oh, well, we don't have enough women on our board, or we don't have enough people from this county, or we don't have enough people representing this interest. So we do our best to have a balance of interests on our board. So what happens if you violate FACA? So the good news is there's no criminal penalties, there's no FACA jail. None of you can be held liable civilly for any kind of money. But the bad news is things that have happened before are litigation that the department has to handle for violating FACA. These are things like if James decides he doesn't want to hear a public comment at your meeting, somebody could complain that's a FACA violation, and we'd have to deal with that. Again, there's nothing that would happen. James would not get fired. Well, he might get fired. I don't know, maybe. But generally, what we try to do is avoid any sort of FACA violations and not have to deal with this. But what has happened in the past is whenever there's been a FACA violation for an advisory board, and we haven't had any for the SSABs for as long as I've been doing this, you erode the public trust. They've had their recommendations thrown out because they have violated FACA. This was an example I posted up here of a complaint by something called the Industry Wind Action Group. They were complaining to the Fish and Wildlife Administration that the people on their boards, there was no one who was an expert in bats and what happened to bats for wind turbines. And so their big complaint was, you need to put someone with an interest in bats on your board. This is not really a violation of FACA, and that actually didn't go anywhere as far as I can tell from my internet research. FACA violations are things like, again, you're not opening your meeting to the public, you're not publishing your information in a timely manner, you're not noticing your meeting. Those are really things that they look for FACA violations. Finding out who sits on a board is a lot harder to prove. As I mentioned, there's no way to really say what a balance is. And the courts have found that no one has a right to sit on a FACA board. There was the first case about it actually happened to the Department of Energy for the site-specific advisory board. It was our Northern New Mexico board, and there was a group of environmentalists who said, we have the right to sit on this board. And it went all the way it went pretty high in the courts, and the courts found that the Federal Advisory Committee Act gives DOE discretion on who sits on their advisory boards, and that no one, in fact, has a right to sit on the board. And that has stood for a long time. And when you take the 2-day FACA training as I have, they hammer this home as something to remember. That's sort of the guiding documents that we use for all of our advisory boards. And each one below it has to sort of maintain all the requirements of the one above it. So we have the Federal Advisory Committee Act. DOE has their own sort of regulations for its FACA boards. We have our charter I mentioned. My office has developed some guidance documents, and then you have your own local board operating procedures. And as long as nothing violates something above it, everything's okay. So I mentioned our charter. I'm not going to go through this too much, but our charter is very general. It allows all the topics you're allowed to talk about, and you can see they're all just basic sort of waste management, cleanup issues, and future use. Some of the responsibilities that DOE has to do under FACA is maintain all the agendas. We have to call and adjourn every meeting. We have to keep records of just about everything for the life of the board. We have to make sure every meeting is noticed in the Federal Register. We have to do an annual report every year. We have to nominate members. And again, ensure that we meet all ethical standards. I'm going to talk about that in a little bit. But basically, those are responsibilities that DOE has. And I should mention to Michael that one of the responsibilities in FACA that it does allow you to do is, if at any point you decide it's in the public interest to end the meeting, you can end the meeting. You have that right. Except when I'm talking, then you can't end the meeting. But some of your responsibilities, I love the SRS cab because you actually put your sort of rules of conduct on the side of the thing, and these are parallel those pretty well. We ask that you attend as many meetings and focus on providing us with recommendations, working collaboratively, avoid bargaining, saying I'll vote for your recommendation if you vote for my recommendation, because that's not in our interest when you're doing stuff like that. We ask that you not respond directly to the public comments, allow the facilitator or the chair to kind of moderate that. Don't use your title to represent the board outside the meeting. You're allowed to tell people, of course, that you're a member of the SRS cab, but we ask you not to say you are representing the SRS cab in any statements that you make. Report to your DDFO if an outside entity is perhaps trying to influence you, even if you're not sure if they're trying to influence you or not. Focus on your board's mission and on your work plan. And again, I mentioned conflicts of interest before. So this slide is the only one that the lawyers had to take a look at. So the good thing for all of you is you're not special government employees. So SGEs is the acronym we use for it. SGEs are members of advisory boards who are experts in certain fields. FACA allows those people to become special government employees, and they are subject to very strict conflict of interest laws. If they do something that is perhaps has a financial benefit to themselves, they are subject to criminal penalties as a result of that. None of you are responsible for criminal penalties. You are considered representative members. You're representing your community, so you're not SGEs. But what we asked you is, as a matter of policy, if you feel like you might have a conflict of interest, if you have a relative who might benefit from one of your recommendations, report that to your DDFO. They're not a huge deal. We have them all the time at our meetings and our boards across the country. What we always say is that you can always recuse yourself from a vote that you might have a conflict of interest for, and it's really not a big deal. So my last slide is what makes an advisory board successful. This was something that the GSA did a survey way back in 2005, and the result that they came up with was advisory boards who know what they're doing, who know what their purpose is. Those are the boards that provide the most successful recommendations. We do that through our work plans, but my advice would be to all of you, if you are unsure what your purpose is here, talk to your DDFO, talk to your chair, talk to your vice chair, and get on board with kind of what your main purpose is, because the more you are aware of that, the better your recommendations to us are going to be. And that's about all I've got. Are there any questions?
Any questions on board operations, Advisory Committee Act? Dave Vivakis, right here.
Dave Vivakis, CAB, thank you for the presentation. Appreciate that. Some time ago, the president signed an executive order that would eliminate advisory boards. Has the Department of Energy made any decisions on the elimination of advisory boards, and how would that affect the Savannah Riverside CAB?
That's a good question. So for those of you who don't know, in August, the president issued an executive order delegating all of the agencies to get rid of 1/3 of their advisory boards. although I do not think that my advisory board should ever go away, there are a lot of advisory boards in the federal government who have been around for a long time and really just get renewed because they have been around for a long time and they don't really serve a purpose anymore. So kind of weeding them out is not a bad idea. That said, I don't have any information on that yet. September 30th is when we're supposed to be making a decision, and those decisions are made at the secretarial level. So I have not heard anything. I would tell you that my own opinion is we should not get rid of the site-specific advisory boards, but I haven't heard anything. Doug?
Doug Howard Cap. David, great presentation. All the advisory boards throughout the nation, are they individually funded by the government, or the monies come out of all one pot? And do all of the advisory boards get the same amount of money as far as government funding?
No. So each agency is responsible for its own advisory board program. Some advisory boards are mandated by law. There's written into a new law that comes out could say, and this agency will form an advisory board. So those are congressionally mandated advisory boards. But it's still up to the federal agency who runs them to manage the budget for those boards. So there's not one big pot of money that all the federal advisory boards come out of. Each advisory board is responsible for reporting how much money it spends or how much is spent on that advisory board in the FACA database every year.
Thank you, Dave.
Sure.
Who else?
So I've got a FACA trivia question. It's a hypothetical. And I've used this one before and I love it every time. So let's say Michael Michelanis decides he's going to have a barbecue and invite all of you over to his house for that barbecue. Is that a FACA board meeting?
Depends on how good it is.
So the answer is no, because this is America and Michael can invite whoever he wants over to his house and have a barbecue. However, if you're all there and some of you start talking about recommendations that the CAB should be voting on, it becomes a FACA board meeting. And then Michael would have had to notice it in the Federal Register. There has to be room for the public to come to for the barbecue, public comment at the barbecue, make enough food for everybody at the barbecue for the public. So we ask that if you are all meeting together as a group, and if you have a quorum, really is what it matters, that you be careful what you talk about. That you can certainly talk about things that the board is doing, but once you start talking about recommendations that the board or potential recommendations, those are things that trigger FACA, and you should be doing that in the public eye. Anything else? No?
Looks like you're getting off light,
All right.
Dave.
Thanks very much, everybody.
Thank you. Thanks. All right, so before we move into public comment next, I want to make sure that we add a few things to our agenda. Nurinder, you brought up yesterday that you want to bring in 356 and 357 for closure. So folks, make sure you add that to your agenda, that we'll be voting on the closure of those this afternoon. Also, I'm going to go ahead, and before we go into public comment, I'm going to pass out the committee chair ballot now, and we'll collect those and get them counted during the public comment period. That way we don't make you wait. So if you will, I'm going to go ahead and hand these out. You have to. And I'm going to immediately come back around and pick them back up. There you go. There is one candidate, but I still need you to check the box and or write in if you disagree with the name in the box. There you go.
I think I'll write in. You know, Greg Murray.
Did I? Oh, Doug wasn't up there. I'll get him in a minute.
I think
We'll make sure that he gets a chance to vote. See if I can do this without tripping on cords all the way around. Awesome. Now we're good. We're good. Drop it in there for me. Drop it in there for me. All right. Thank Thank you. Well, if I can navigate this without tripping over wires twice, it'll be a good day. All right. There you are, Delisa. All right, so the last time I checked public comment sign-up sheet, and I'm going to check it one more time, but I believe there was just one name signed up. So if you want to get ready. Yes, just one. Man, will you come up to the public microphone and identify yourself for the meeting minutes?
Thank you. I'm back. I've been missing for about 3 months. I'm Cece Anderson. I'm a research scientist also with Georgia One. And on yesterday, I might be redundant about some of the comments that I have to make, and I'm very concerned about the public not being involved. I just want to bring out a couple of things. I was concerned about the training and hiring and risks and hazards of all the shifts that was mentioned today and yesterday, about the training of the first and second shift or whatever the process may be. And I was concerned about the completion, whether you get a certificate or license or you be moved to a particular area, and how often are the trainings and the continued updates are monitored. Then I want to speak about the containers, very concerned about the double stack, which is concerning with the glass waste storage and how deep it is on top of each other from crashing or crushing, and the monitoring leakage, spillage, erosions, or what have you, due to the process. And I wanted to find out for sure. I know it was mentioned somewhat on yesterday about the soil, how deep it was, but I'm not sure, and that's one of my concerns. Also, the removable process of the infrastructure, the conditions of the tanks, when you're replacing them, and how often from the leakage and leaking inspections are they being changed out, and is the public aware when these things are happening? Also, the storage process. We just keep on adding and building, and it's becoming a bigger storage container process to hold more and more. It's just like feed me. And eventually, we're going to run out of space, which has its own community and neighborhood. I thought I'd throw that in there. And not a whole lot of room for mistakes. I want to speak about again, the waste tank status, the cleanup, the closures, and also the suspensions and the milestones that was mentioned today. And I need to see show comprehension plans and the standards that need to be presented to the public. And also, what is needed in a summary of the conclusion made during the second day of the meeting, like today, so that the public will be notified of the status and what was done and said. The public also needs to know about the funding and the cost, because some of this cost is overrun. I mean, my goodness. And when does the public have an opportunity to visit these sites for tours, not just for the meetings and the hearings that are done on a bi-monthly or every other month, every other week process? So those are my public comments, and I'm sure that we need to do more to get out the public to get involved before something drastically happens. Thank you so much, James.
Thank you, Cece. Does anybody else from the public wish to make a comment at this time? Seeing none, let's get in it. So, Heather, I don't remember, which one do you have up first for? I know it's the voting for the recommendation first. Okay. So let's do this one. Greg and Narinder, will you cover it real briefly where we're at right now?
Greg Murray, Cab. Where we are at right now on this recommendation, this is something that had gone through the Nuclear Materials Committee. Narendra and I had put it together. The Nuclear Materials Committee passed it up for full board consideration. We okay, James?
Well, yeah, we got the votes out of order, so let's do this.
Oh.
Can I get you to hold on to that?
Of
because
course.
rearranging these is actually, it breaks the voting sometimes.
Okay.
So let's do this in this order, looking at the slides. It's going to be the NERP support, then we'll do plutonium, and then we'll do 356 and then 357 in that order, okay? Recommendation was under nuclear materials. So NERP support was under strategic and legacy management. Dave, am I correct that the committee voted to close this recommendation at the last meeting?
The Strategic and Legacy Management Committee recommends closing requisition number 362, which is the SRS NERP support, which is the National Environmental Research Park.
Okay.
We're going to vote to close, to follow their Strategic and Legacy Management Committee. If you are in agreement, please press, and if you don't have your clicker, it's underneath your nameplate, if you haven't seen that yet.
Yep. Get your clickers handy, folks, right up under your nameplate.
So if you are for closing this recommendation, please press 1 or the green button. If you're opposed to closing it, please press 2, the red button. Go ahead and vote now.
Or abstain is the...
No, I don't give that option.
You don't like giving that option? It's an option.
I don't, did Tom step out? So I think we may have one extra.
12, 14, 16, 18, 20. You got, there we go.
So we have 3.
Who has number 8?
If you'd flip over your
10,
clicker
9,
and
8.
see what number you have. If you have number 8, please raise your hand.
Yeah. Who has number 8? We changed the batteries. I promise. Yours worked. It recorded your vote. No, it didn't. No, not 19. Heather, swap out. Give me another one real quick. It even says it's okay. No, it recorded your vote. Give me number 8. Yeah, I bought the batteries. They were an Amazon order from China. Been getting all kinds of weird emails. There we go.
8 just showed. How about 8, 19, and 20? Are they not being used?
We're good.
Okay. All right. And we're going to make a little bit of idle talk as Heather makes her way back to the computer and she can show us the results.
So she's got to flip over and change the results.
So we're not going to make her run.
Sorry, Bobby. I bought bad Chinese batteries. I'm sorry. That's what happens.
And the vote carries 95% positive.
All right.
All right. So we have closed recommendation 362.
Now don't vote yet. Let's hold our votes for just a minute. Now, Greg, please. I apologize for interrupting you earlier.
That's fine. All righty, Greg Murray, Cab. Okay, so we were in this recommendation regarding the plutonium surplus disposition. We had gone through it yesterday. There were some comments about it. A couple of CAB members raised a couple of questions that I've got some information on, if that's appropriate, and that's what we want to do, James. And otherwise, whatever you suggest we do from here, I'm glad to do.
Greg, can you do me a favor and read the recommendation, just the recommendation portion of it, not the background or research, just the recommendation?
Of course.
Thank you.
James, did we make those edits from yesterday?
Yes, we made that edit. We didn't have time to reprint for everybody.
So if I'm understanding then, the recommendation then is for the CAB recommends that DOE take the steps necessary to accelerate the dispositioning of the 6 metric tons of surplus plutonium and to complete the dispositioning process no later than FY 2036.
Yes.
That looks right.
That's it.
That's it. All right. All those in favor of accepting this recommendation as written, please press 1A. All those against, please press 2B or the red button. Or if you feel like abstaining, I'll give you that option. Hit the yellow button.
Thank you. It's America. The right to do nothing is also enshrined.
The choice to do nothing is making a choice.
It is. All right. That's all our responses.
All right, Heather, what do we have? Okay, we have a 95% yay, and we did have some people choose to abstain. So this recommendation will be forwarded on to the Department of Energy, Savannah River. Moving right along.
356. Narinder, can you briefly talk to that? No, I really don't. The response has been out for quite some time. Everyone has had ample opportunity to read 356 on repeat. We put it on the notifications for the August committee meetings. I mean, if you haven't read it by now, likelihood you're not going to.
Narendra Malik, Cap. In this recommendation, there were 4 recommendations, and DOE has accepted 3 of the recommendations in full and 1 in partial because the latter part requires DOE order 435.1 need to be revised to meet the requirement. So I will ask board to reconsider it for voting and accepting the response from DOE.
Okay.
All those in favor of closing recommendation 356, please press 1A. All those opposed, 2B. Anyone wishing to abstain, 3C. Didn't record me. Oh, there it goes. If you have 3, 7, okay, there we go. 5 and 7, please. 5 is in. It's like C-SPAN.
1, 2, 3, 4, 5, 6, 7. It should be yours, Candace. Is it recording yours?
Mine is 37.
Okay. Yeah, you're number 7. Oh, got it. It recorded. Okay, thank you.
Okay.
All right.
Let's see how we decided on that class cancer.
And what's the vote? Or the results?
I'm saying it's 95 to 5. So.
Probably. We'll see.
Oh,
100%.
we have unanimous. Okay, we all agree to close. Recommendation 356, that is closed out. Moving on to recommendation 357. Narinder, can you give us a brief synopsis?
It was submitted, the canisters, I don't know, is canister, I don't have the, it should be sent as a TRU waste to WIP, and it was recommended with the note that WIP has been notified that this waste may be coming. So this DOE SRS has accepted the recommendation.
All right.
Okay, all those in favor, please press the green button. All those opposed, please press the red button. All those wishing to abstain, please press the yellow button.
There we go.
Okay, we're in. And we have another
100%.
unanimous vote. All right, thank you very much. And we have one more vote to discuss.
Yes. Oh my goodness, Greg. Unanimously elected by the board members.
A unanimous vote.
So thank you very much. We look forward to it. I'll get with you later and I'll tell you all the things that are left on your plate.
All right.
Gil, that's everything on my agenda.
Everything on mine as well. So
you want to close it out?
I do. Wonderful meeting. Waste management, you guys have your hands full. You got a lot of great information today. When is the next Waste Management Committee meeting? Sorry. It's in October. Okay. Well, I ask everyone on the Waste Management Committee to make every possible attempt to get to that meeting. You have a lot to go over. There's a lot of great information. For those of you that have been on the board for more than 2 years, you've learned a lot about SWPF. Today was the most we've heard about it in detail. So there's a lot of information coming out about that. I would ask, just on a personal, as I listen to things, I would ask that you really pay attention to that the salt solution. They gave us a lot of information on that and how they're going to create it and all the water that needs to be used in the tanks. those of us that have been on the board for a while, we've heard a lot of questions over, are we going to be able, someone actually referred to SWPF as a Ferrari at one point. So are we going to have enough gas to put in the Ferrari? So it's exciting. We are going to see a lot more production come out of the liquid waste program. I understand Jim Folk had a family emergency, so he couldn't attend this meeting. I know he'd been excited. I mean, this is his baby. So we do look for some great recommendations coming out of waste management. Also, the other committees, we have a lot going on. So please make every attempt to attend those meetings. Point of order, is DOE going to give us guidance before the next full board meeting on the changes?
We'll have information for you. If not before the next meeting, we'll have it ready to talk about the executive committee next time. We're going to take the feedback that we got from you all yesterday, and we'll be working it. Gil, if I need any additional interpretation or some guidance from the CAB, I'll be calling you directly.
That's cool. That's great. Thank you. The only reason I was asking you possible quorum issues at committee meetings, that we'll leave those as they are now, Michael.
We'll get back with you on that. I would like to implement the quorum as soon as possible. With Jim being out, I just want to have a discussion with Jim before we make a change. I'm ready to make a change today to make the quorum issues go away for the committees, just because, for all the reasons that we talked about yesterday.
Great. So even with that said, it's extremely important that all of us go to our committee meetings. I'll make every attempt to attend all the committee meetings. I know Doug makes every attempt to attend all the committee meetings as well. So I really ask that we put a point of focus on that. Other than that, I hope you've had a wonderful time here in Charleston. The Francis Marion Hotel has been a wonderful host. I don't know if you've had any issues with the staff. I've had absolutely zero, and they've gone out of their way to try to make my stay better. So I hope you enjoyed yesterday evening. For those of you that are staying tonight, enjoy Charleston for one more night. If anyone noticed, it felt like the humidity picked up a little bit today. So enjoy the weather. But the next meeting, I believe, will be in Augusta, Georgia. And let's see, we are in September, so that'll be in November. And for those of you that have not had a chance to be at Hyatt Place downtown on Broad Street, it is a wonderful place to have a meeting. So I look forward to seeing all of us there. Tell your friends, tell your family, and we'll do this again in 2 months. Thank you very much. Meeting adjourned.